Okay, 2.17. This one is volume and surface area. We're going to go ahead and just go right to the problems and not do the explore problems. Volume is measured by taking the length times the height times the width. There's all kinds of formulas for these. So the way that this book does it is it looks at the surface area of three-dimensional objects, and they break it down to let's say blocks, and then they figure the surface area for, in this case, one column or the face of this, and then how many of these columns we have, and that's how they figure out the volume of those. So let's look at number 2. It says find the volume of each object, counting the number of cubic units. Assume that there are blocks that you cannot see. If they are necessary for the structure, find the surface area of each object by counting the number of square units. Well, if we look at the face or the surface area of this first higher one, the surface area here is going to be 4. And let's see, there's going to be 4, well, let's see, 1, 2, 3, 4 of those 4 blocks. So we got 4 plus another 4 is 8, plus another 4 is 12, plus another 4 is 16. Now we're going to look at the next section here. As long as it's consistent and the same, we can do the same thing. So I have one block here with a surface area of 4. So this shaded area is going to be 4. And so I have 1, here's another 4 here, and here's another 4, and here's another 4 blocks. So again, I've got 4, 8, 12, 16 of those. You add those two together, and I get 32 units cubed for the volume. And we'll do the same thing for this next one. Here I have 1, 2, 3, 4 for this surface area. Let's see, how many columns do I have? Well, I have the 1, 2, so there's another 4. There's another 4 column, and here's another column with 4, so that's 16 for this one. Let's see, I have a surface area here of 3. So I have the 3 here, another 3, another 3, and another 3. 4 times 3 is 12. 2 surface area. So this is a 2 column, 2 column, 2 column, 2 column times 4 is 8. And the 1 column, 2. This actually will do this. It's a 2 surface area. So I have 2, 4, 6, 8. If I add all those together, let's see, 16, 32, 42, 44 units cubed. Okay, next page. The next page actually works with the formulas. First one, I have a formula here. I'll always start with your formula too. Volume equals 1/3 pi r squared times height. So I'm going to need the variable r, and I'm going to need the variable h. So my radius of the circle, the bottom here, is going to be 4 centimeters. And my height of this cone is 6. So I just go ahead and plug those into the formula. 1/3 times pi times 4 squared times my height, which is 6. And then I'm going to need a calculator. So I get 1/3 times pi times 16, which is 4 squared, times 6. And it gives me approximately 100.4 or 100.5 centimeters cubed. Okay, B for the sphere. It's the same thing, my radius, here's the formula. I need pi, and so the only thing I need here is my radius, which is 2. So my sphere equals 4 pi 2 squared. Put that in my calculator. And I get approximately 550.2 inches cubed. And the last one, let's see, I need my W and I need my, oh, I forgot the L, and the H. Width is, and it doesn't matter which one I call length or width, 7, 5, 12. So I got 1/3 times 7 times 5 times 12. I get 140 inches cubed. Okay, 4, a company intends to sell less of a food in a package and reduce packaging as well. The company's area box currently has the dimensions 11, 7/5, 2 3/4. Vice President asked for the reduction of a half an inch on each dimension with the idea of reducing the size of the packaging out to save the company money without being drastically changed noticeable. Find the percent change of the volume of the box. So the percent change of the volume. So we need to find the volume. So we need volume 1, the original. Volume original equals, this is a rectangular prism. It's a box, so it's a rectangular solid. So it's going to be length times width times height. My length, 11, and my width, 7 5/8 times 2 3/4. So plug all that into a calculator. Now this is the original one. So I have 11 times 7 and 5/8 times 2 3/4. I get 72.2 approximately. And the new volume of the new is a half inch less, so I have 10.5 times half inch less is 7 1/4. Because 5/8 minus 4/8 is 7 1/4, and 6/8. I'm sorry, 2 minus a half is 1/4. 3/4 minus a half an inch is 1/4. I'm going to use decimals. It's going to be easier on my calculator because I'm using my phone. So I have 10.5 5.5 times 7.25 times 2.25, and I get 100. Oh, that doesn't make sense. Should be smaller. Let me see if I did this correctly. Okay, this one I multiplied out. Should be 482.3. Did it wrong in my calculator. So this one was 10.5 times 7.25 times 2.25. 171.3. That's a significant difference. And they want to know the percentage change. It's going to be the different, remember, percent. We don't know what the percent is. Over 100 equals the difference. 482.3 minus 177.3. 305 over the original. Cross multiply, so I'm going to take 305 times 100 and then divide that by 482.3. 63% difference. That's significant. The original box held 12 ounces of particular cereal type. Estimate the amount the new box will hold. Find the percent change in the cell. It's going to be 63% of 12. So I get 7.56, so 12 minus 7.56. You're only going to get about 4.5 ounces cereal. Find the percent reduction in package needed is the same as a percent. Find the percent. Is it the same as the percent reduction in volume? Of course not. We proved that. And that's it for section 217.